Hello, Earth Science. I want to go through this concept of landscapes with you. Landscapes is almost like a unit and a lesson all in one, but it wasn't until now that we could talk about it because you needed to understand rocks, in particular sedimentary, metamorphic, igneous, and the differences between them. We also need to understand weathering and erosion. When we take these two things together and combine them, we get landscapes. I'm sorry that I can't put this on full screen. But when I do, I'm unable to navigate it with the recorder going today for some reason, so I'm going to have to do it from the column here. But landscapes, we're looking at a couple things, the height of the land and the underlying bedrock. So in this picture here, you can see that this landscape is different from this landscape. So landscape 1 and landscape 2. Now I'd ask you to take a second and consider, how are these different? Here's 1. Here's 2. Typically, if we do this in class, it only takes a moment or so before someone says, this one's really dry. And I say, correct. How do you know? I don't see any trees. Right, there's a lack of vegetation here, which usually corresponds to a lack of water. This one looks pretty wet. Why? There's trees everywhere. Yep, it's probably a wetter climate. This one looks sharper. Wait, what do you mean? Well, like the top looks like it's got jagged edges. Great. This one looks more rounded. I agree. Looks a little smoother. This one looks like if you fell off it, you might die. True. This one looks like if you fell off of it, you probably wouldn't die. You would just roll down a hill and maybe get hurt. True. I will tell you guys that from an earth science perspective, these are both of these landscapes are considered the same thing. This is a plateau, which you probably aren't surprised by. You're like, oh yeah, I've heard of that word in desert places that are orange. This is a plateau as well. This is just a plateau in New York State. Really? Yeah, it is. It's clearly more rounded. It's gotten weathered more because we have a wetter climate here than this one here, which I believe is in Utah. But what makes them a plateau? That's what we want to look at today. So first of all, in your Earth Science reference tables on page number 2, there's a page called Generalized Landscape Regions of New York State, and they give you the names of the different landscape regions. You can see that here in Mayville, we live on something called the Alligator Plateau. If you happen to live in Ripley or down near Westfield, you'll live in something called the Erie, Ontario Lowlands. Here I have the Adirondack Mountains circled. Just as a point as we move to the next page, you'll see why I circled it. But you'll see here that the Catskills are considered a plateau. This picture here is actually of the Catskill Mountains, but they're not mountains. It's weird. People call them mountains because they look like mountains. So when people first got to New York State from Europe, they're like, hey, look at those mountains. So we call them mountains. But actually, they're considered part of the Allegheny Plateau, the same plateau that we're sitting on right now. So take a look at this for me. The Adirondack Mountains, I have them circled here on page 2 of the reference table. When I go over to page 3 of the reference table, I see all these squiggly wild lines and things like that here. If I were to go down to the key here and look at the rocks that make them up. So what I'm talking about here is on this table, there's in lowercase font, not capitalized. It'll tell you the kinds of rocks are making it up this particular region. I'd like for you to ignore the capital letter ones because those are referring to geologic time, which is that one unit we haven't studied just yet. But if I look at the type of rock here, what I'm going to find is that everything that's in here is either igneous or metamorphic, and that's actually half of what makes a mountain a mountain. In order to be a mountain, your bedrock has to be either igneous or metamorphic. A plateau, your bedrock has to be sedimentary. So this whole area here, this Allegheny Plateau that we just looked at here, come over here and look at it. If I look at what it's made out of, it's made out of sedimentary rock, including the Catskills. This is sedimentary rock that's been eroded away, which makes it a plateau. The Adirondack Mountains are actually mountains from an earth science perspective because they're made of granite and also some metamorphic rock. So granite's an intrusive igneous rock. They're made of some metamorphic rocks as well. So they're a true mountain. The height of the landscape is what we call relief. So you guys can record this actually. I'll pull this over. Set this up right here. There's a sheet I made for you to to help you with this, and this one just says define relief. So right here is where I'm referring to. This is what relief is, and this is what you can write in that space. The vertical difference between a peak and a neighboring valley, aka how tall the landscape is. So if we say that a landscape has high relief, we're basically saying that it's tall, meaning that if you go from the peak of that landscape to the next valley over, you have to go either up or down a whole bunch of elevation. So it's tall. If we say it has low relief, then it doesn't have much elevation change between a peak and a neighboring valley. So I'll give you one more moment to write this. The vertical difference between a peak and a neighboring valley. This is what relief is. And I'll just give you guys some examples. High relief, this picture here on the left has high relief. These giant sides of a plateau here, I could tell they're a plateau. I could see layers of sedimentary rock here, but high relief. Like if you fall off of this, oof, this thing here is some soil, but low relief between this peak and the neighboring valley. You might even laugh calling this little thing a peak, but in earth science terms, this would be considered a peak. And then the next valley over is like, I don't know, a foot down. If you fall off of this, you probably will just feel a little silly and stand back up and see if anybody was watching, because it's a very, flat land here. So let's take a look at all three of them. Now, again, going back to here, there's a space for each one. So landscape name, and New York State, city, or town that's found in the region. Rock type and relief, we're going to kind of start here, and then the profile diagram. So you guys are going to do this and this with this slide. So a mountain has high relief and is made of igneous and metamorphic rock. So high relief and igneous and metamorphic rock are going to belong in this block right here. And the profile diagram is just this. Kept it pretty simple. Igneous and metamorphic rock, high relief. And that's going to go right here. So you have your words here. You got your diagram right there. Now for the New York State town or city that falls within that region, what we want to do is first kind of identify what we're talking about here. So here's your mountain region right here on page 2. So that tells me, okay, we're looking for a town or city in the Adirondack Mountains. The towns or cities are listed on page 3. The landscape names are listed on page 2, but it's okay, they're right next to each other. So I come over here and I see that there's a town here called Old Forge. And that seems like it will be a good one. So in this particular thing here, you guys can write mountain, Old Forge. Nice little town. If you guys ever spend time in the Adirondack Mountains, I know some of you do. Okay, then moving right along, take a look at a plateau. So a plateau is high relief still, but the difference between a plateau and a mountain is a plateau is made out of sedimentary rock. So this profile diagram is going to go in your third box over, second row down. So right here is where you're going to draw your little plateau diagram here. And then make sure you note that there's high relief. Then made of sedimentary rock and high relief, the words are going to go right here in this middle box. Plateau, high relief, made of sedimentary rock. So as I mentioned already, our school is on a plateau. Some of you live on a plateau. I happen to live on a plateau now. I didn't used to when I first started at Chautauqua Lake, because I lived that time. I lived in Buffalo and I commuted for a couple of years before I decided I was really going to stay. But at that time, I lived on a plain and was commuting to a plateau. Now I live up on the plateau, but whatever. The main thing is that if you look in the Earth Science reference table, you'll see that, let's go to our plateau first. Right here, the Alligator Plateau is the big one, going all across what we typically refer to as like the Finger Lakes in the southern tier of New York State. Lots of cities to choose from. Jamestown. They have Buffalo listed on the plateau. I'm sorry, Buffalo's not. Buffalo is on the Erie, Ontario lowlands. So Buffalo doesn't count. Jamestown, Ithaca, Elmira. I think that's it. So one of those towns. I'm going to go with Jamestown because, well, Stock County. So I'd say Plateau, Jamestown. You guys can choose Elmira or something else if you don't like Jamestown. All right, and then the last one is probably the least exciting one in terms of earth science, and that is going to be a plain. Oh, where is that guy? That slide got moved. Plain, low relief, and made of sedimentary rock. So the words in the middle column, your third middle column, and the diagram in your third box over, bottom row, right here. So here's your plane. Here's your words. And again, we got low relief here. Not a lot of elevation change in a plane. And the cities are plentiful because people like these areas generally. Of this plane kind of follows the 90, except for this one part, it has to go through a plateau. But if you look across New York State, you got some big ones here: Buffalo, Niagara Falls, Rochester, Syracuse, Utica, Albany. All of these fall within plains. Oswego, Watertown, Messina, lots to choose from. So you just pick one. Just to be a little bit different, I think I'm going to go with Messina here. Messina. Right now, what I want you to also note about the plain, I'm sorry, about the plateau. The plateau was never pushed up. Sorry, I have a little card drawn up there. I think I was explaining something to someone else at one point in the past, but these rock layers are flat, so they were deposited. The old former ground here used to be here. The ground was here, and it was since eroded away. Like these parts were eroded away by some agent of erosion. A lot of times in New York State, it's ice, but either way, these were never pushed up. So the Catskill Mountains were never pushed up. They were just eroded around, and what's left is what appears to be these mountains. Another thing too about plateaus: in a dry environment, they're going to be more angular. In a moist environment, they're going to be more rounded, because you just have to think about, if you had poured water over top of this landscape, what would it do? It would turn more rounded, and it would turn, well, just more rounded, really. That's all I'm trying to say. So, in your sheet here, it goes a little bit further here. It says, list 3 leveling forces that have produced landscape features in New York State. Leveling forces, what could that be? Well, we're talking about agents of erosion. Remember, we have a few here. But let's go with some of the big guys in New York State. So New York State's a pretty wet environment. So we're going to get a lot of running water. Glaciers are another huge one. And then, believe it or not, because of our proximity to oceans, especially down near New York City. Oops, no, that was right. I don't know what I was doing. Waves. Describe how a landscape in New York State could be in a state of dynamic equilibrium. Remember, this means imperfect balance. So what we're looking for here is for you to describe how a landscape could be in perfect balance between erosion and, say, uplift. Erosion and uplift. How could you make that in perfect balance? Go ahead and give that a try.